So in today's video, we're going to delve into higher order implicit differentiation. And so we're all familiar with just the notion of higher order derivatives where we apply the derivative operator multiple times in order to get, the second derivative, the third derivative, etc. But in today's video, we're going to actually look at how we can extend that notion into implicit differentiation. And so in the previous video, we looked at this expression over here, x squared plus y squared equals to 1. You may recognize that as the equation of the unit circle. And we were able to determine the derivative using the chain rule. I've actually written the chain rule out over here in case you need a reminder. And we got this expression. We got dy by dx equals to negative x over y. And we have an expression now written, in terms of x and y. So we have y written as an implicit function of x. And we also have dy written as, or dy by dx written as an implicit function of x and y. And so now what we're going to do is we're going to actually apply the derivative operator again in order to get d squared y by dx squared, or the second derivative of y with respect to x. And so before we actually do that, I'm going to try to make this a little bit easier, this expression over here, so we don't have to use the quotient rule. I'm going to multiply both sides by y. And so then we'll end up with y dy by dx equals to negative x. And this is just to kind of use the product rule. It's a little bit easier than the quotient rule sometimes, but I mean, you're going to end up with the same result anyways. And so now what we can do is we can actually go ahead and apply the derivative operator to both sides. So let me do that. We get the derivative with respect to x of this side equals to the derivative with respect to x of this side, which is negative x. And so let's actually, we can go ahead and simplify this portion over here. We know that we'll end up with, so the derivative with respect to x of y times dy dx equals to, we know that the derivative of negative x is just going to be negative 1, right? This just comes from the power rule. And so now we can actually use the product rule to simplify this expression over here, to actually take this derivative. So we know that we have two functions. We have the product of two functions. We have y and we have dy by dx. And so what we can actually do is we can go ahead and just treat this y as like the first function and this dy by dx as the second function, and then we can apply the product rule, which tells us that if we're taking the derivative with respect to x of f times g, these are just functions, I omitted the function notation though, then that will just be f prime g plus g prime f. And so if we say that this right over here is our f and that this is our g, then we can just go ahead and apply the product rule. So let's actually do that. So the derivative with respect to x of y, well, that's just going to be dy by dx, and then we can multiply that by the derivative of y with respect to x. And then we're going to go ahead and add that to the derivative of our second function, g, times the first function. So our first function is y, and our second function is dy by dx, and so when we take the derivative of dy by dx, that's just going to be the second derivative of y with respect to x, and we're just going to multiply that by y, and that's equal to negative 1. And so now what we can do is we have this expression over here. We have dy by dx in our expression. But in the previous video, we were able to determine that dy by dx is just equal to negative x over y. So we were able to get this kind of expression for the derivative with respect to x. And so we can actually go ahead and input negative x over y in place of dy by dx in order to kind of simplify our work a little bit. So let's actually do that. And so here we'll get negative x over y times negative x over y. Let me actually change colors for the sake of nothing really. And we're going to go ahead and add that to d squared y by dx squared times y, and that's equal to negative 1. And then this expression over here, we can simplify it. We know that negative x times negative x is just positive x squared over y squared, because we just have the y times y, plus the second derivative of y with respect to x times y equals to negative 1. And now all we have to do is just some simple algebra in order to actually solve for the second derivative of y with respect to x. And so what we can do, I'm going to move this up here, we can subtract x squared over y squared from both sides. So we'll get that the second derivative of y with respect to x times y is equal to negative 1 minus x squared over y squared. And then finally, we can divide both sides by y to solve for the second derivative of y with respect to x. So we will get the second derivative with respect to x is equal to negative 1 minus x squared over y squared divided by y. And then we can simplify this even more. We can just end up with the second derivative of y with respect to x is just equal to negative 1 over y minus x squared over y to the third. And that right over there would be our final answer. And so essentially, the point is you can just take higher order derivatives for implicit functions, or, well, through implicit differentiation, by kind of just determining the first derivative and then differentiating that and using your expression for the first derivative in order to actually obtain the second derivative in terms of both y and x rather than dy by dx.